please. Now, as I was looking at your quizzes, I thought you did a really good job as long as we look at it through one particular prism. If this is the end-all, be-all of our learning how to do Regents-type questions, they're not good enough. They're not bad, but they're not good enough. If, on the other hand, we look at this as what it truly is, which is the first time you've really been given Regents questions and asked to get them right, I thought it was an outstanding start. A very, very, very good start to the kind of questions you can expect to see and what you can expect to have going on. So, let us go through this. It's got a little bit of what we've been doing recently, a little bit of review, and a little bit of stuff that kind of orbits around what we've been doing, but is not exactly what we've been doing. So, for you to be successful on this required less methodical program type of thought and more independent thought on your part. So if you did a good job, that's excellent. Now every person is going to stop doing tonight's homework. Very discreet. And now we're going to pay attention to the quiz. First off, on number one, the answer is 2, and just about everybody got the choice 2 for number 1, so I don't need to spend much time on it. Basically, profit is 8,600 minus 22x, and 22 is the hourly rate, so what does x have to represent? It's the number of hours. That way you can figure out that part. Now we're going to go to the inequality. Ready? So clearly this is an opposite side, opposite operation situation. Agree? Oh, by the way, the way this quiz will change is tomorrow you probably get a question that looks just like number 1, but it might say, what does the 8,600 represent? Or it might say, what does the 22x represent? So I'll just change what each part of it represents. All right, so now, this is an opposite side, opposite operation situation. I add 2/3 x to both sides. Die, 7 is less than 5/3 x minus 8. Now, we know at this point in time how to do that on the calculator, but you could also say 1 whole is 3/3, and 3/3 plus 2/3 is 5/3, okay? Or you could do it on the calculator, 1 plus 2/3. Remember, there's really a 1 in front of that x. So you have to do 1 plus 2/3 if you are a calculaholic. All right, next, add 8 to both sides. Die. 15 is less than 5/3 x. And we're doing things very algebraically here, or very blood and guts kind of approach. We'll do the slicker way later. Divide by 5/3. Divide by 5/3, die, x. And then 15 divided by 5/3 is 9. The problem is that that's not one of the choices. And you have to know how to manipulate it. Ready? Brian weighs less than Mr. Lindquist. Is that true? Okay. Isn't that the same exact statement as saying Mr. Lindquist weighs more than Brian? Right? It just depends on how you want to look at it. Okay. So I go over here, it says 9 is less than x. The problem is with inequalities, almost never do we ever put the variable on the right. We always put the variable on the left. And what you need to remember is this. If it points to the 9 here, it's got to point to the 9 when you reverse the thing around. Look at what these two statements are saying. They're saying the same exact thing. Ready? X is bigger than 9. 9 is smaller than x. Same exact statement. Just depending on how you look at it. Okay?
Or the order?
What was that?
Or the order of how you say it?
Right, exactly. But the answer they gave was x is greater than 9. So one of the steps that they wanted to see if you could make was that little transition at the end of the problem. Okay? Any questions? All right. So now we go on to number 3. And number 3 talks about area of a rectangle. How do I find area? Oh, everybody, just talk. Multiply the length times width. Good. So it says in here that the length is 2x minus 6. God bless. and the width is 3x minus 5. So if I want to find the area, I have to multiply, and if I'm going to multiply a binomial times a binomial, what do I have to remember to do? Double distribute. So, first I distribute the 2x, cover up the negative 6. 2x times 3x is 6x squared. 2x times negative 5 is negative 10x. Now I'm going to cover up the 6, danger, 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 so cover up the 2x, I'm sorry. Danger, 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 what kind of 6 is that?
Negative.
So negative 6 times 3x is negative 18x, and negative 6 times negative 5 is plus 30. Now,
Oh, and
always combine in the middle.
so that would be
6x squared minus 28x plus 30. Okay? All right, any problems on that guy?
Nope.
All right, I got, like, I don't know, a piece of cashew or something in my throat, so I need a drink.
Now that's nuts.
All right, yeah, someone has a highly nutty sense of humor.
Oh, good one.
All right. You know, I should say thank you because I am a weird person. I don't know if you figured that out yet. I really truly am weird. When I look at the things that matter to me in life, and when I look at what has real importance, I lived through something. I lived through a lot of things, actually. I consider it a blessing when different people, kids, are in my life and what they bring to it. The enthusiasm, the desire for a better life, the willingness to work hard, and you're at the top, man. You're a funny kid. You're all right. You're really all right. So it's a good thing, and I'm a lucky guy. All right, now this is I combine like terms, so 6x squared minus 28x plus 30 is the correct answer. Are we good? All right. Now let's go to the last one. Ready? What is the thing? There's a charge. There's two charges in here. There's 79 cents and there's $4.50. One of those charges is done only once, and one of those charges is done repeatedly. Which one is done only once and which one is done repeatedly? Okay.
$4.50 is done once.
Right, because that's your admission fee. You walk in, you pay $4.50. Then what do you pay?
75 cents.
79 cents per ride. So you have to multiply the two of them. Like if it was $2 per ride and you went on 5 rides, how much would you spend? $10. And the way you get 10 is you do 2 times 5. So you're looking for the choice that multiplies not 4.5 times the number of rides, because 4.5 was the amount to get in the door, and you only paid that once. But you want the 0.79 times the rides. So that means it's either choice 3 or choice 4. And then you solve the inequality. So 450 plus 0.79R is less than or equal to $16, because that's how much he goes to the carnival with. I minus the 450 from both sides. A little algebraic application here. Die. 0.79R is less than or equal to 1150. Divide by 0.79. And I come up with R is less than or equal to 14.4 something or other. I don't remember what the calculator said.
It was like 14.55.
For 55, okay. The bottom line is, how many rides can you possibly take? 14 rides or 15 rides? 14. If you tried to go on a 15th ride, you would not have enough money. So the answer would be 14 rides. Okay? That's an interpretation of an inequality. Remember, any number that's less than or equal to 14.4 or 5, whatever, any number that's less than that is a solution. 15 is not less than that. 15 is greater than that, so it's not a solution. Any questions? Preguntas? Go ahead.
Can we go over 3?
Yeah, sure.
Oh, that was okay.
Okay. Any other questions? All right. Now, let's get on to today's work. So, you know what tomorrow's quiz will be like, right? No great big secrets here. All right, so now we're going to solve an inequality just like we did on yesterday's sheet, and we'll take a look and see where we come up with it here. So, I might, oh! Copitude. Minus a 5 to both sides, die. Negative 2n less than 10, danger, danger, danger. I divide by negative 2, die. N is what? I agree with negative 5, what about the sign in the middle?
Oh,
Everybody,
Less than.
greater than. Yeah.
Kind of looks like a less than.
It does, but when you divide by a negative, you gotta switch the inequality.
Oh.
Oh, famous last words, buddy. Now, what you want to make sure of is, once again, we explained this yesterday, when you're dividing here, ready, look, you're dividing by both the negative and the 2. The dividing by 2 gets you the 5. When you divide by a negative, it negates everything. It negates this side to make a positive n, it negates the 10 to make a negative 5, and it negates the sign. The negation of being less than is being what? Everybody? Greater than or more than. Okay? If I have less than $1,000 in the bank and then I negate that, I have what?
More than.
More than. Hannah.
If the 10 was a negative 10 and you divided by a positive 2, would that affect the?
When you multiply and divide by a positive, the answer stays the same, or as the first sign. And if you divide by a negative, it changes. So if I started with a negative 10, and I divided by a positive 2, that would come out to be negative 5. Because I started with a negative, I divide by a positive, that sign stays the same. However, if I made that a negative 2, then I would change it.
Yeah.
Okay? Okay, yes?
So when there's only one sign, but it's just like in the middle of the fraction, that means they're, it's altogether negative, or they're
Yes.
both negative? Or?
Yes. Well, no, the only thing it doesn't mean is they're both negative. If you put, let's say you have negative 1/2. That is the same exact thing as negative 1/2. It's the same exact thing as 1/-2. So those are all the same statement. The one thing it is not is that. Because that would mean you're negating both top and bottom, and there's only one negative sign to negate it. Okay, yes?
So when you divide by a negative, then the sign changes?
Yes.
Wait, when you divide into a...
Into doesn't matter, it's by. Because when you're dividing by, you're both dividing by the 2 and by the negative. When you divide by the negative, its job is to negate everything.
So in this problem, if the 10 was negative, not the 2, then the sign would stay the same?
Yes.
Okay.
Okay. Now, let's take a look at the next one. In the space below, graph each one of these. And this is kind of a review of, oh, well, actually, these are a little tougher than you do in 7th grade, I think. This is a bounded interval. It's like this. Right? Everybody agree? Little bracket notation. What you need to do, in breaking this down, it's very, very simple. The endpoints, if you will, are -2 and 5. I don't think that's challenging at all. -2, 5. I have to make a circle in between and fill those circles in. Why do I fill the circles in? Okay,
Because you're showing less than or equal to.
that's right, the or equal to. Now, it's funny, in the next class, 3rd period, we asked them, who was it? Oh, Sean Beatty, also known as Antonio Brown. He was sure.
He's in Jemima.
Oh, now he's in Jemima?
Yeah.
Okay. He was positive that if you graphed this, you fill the circle in. And I said, no. And then he said, then Miss Lenati taught me wrong. And I said, that's not true because I taught Miss Lenati back when she was in 9th grade. So she should have known
on
better.
her wedding in 6th grade.
What's that?
She was way too focused on her wedding to teach.
Was she?
Yeah, that's all she talked about.
You should know
I'm
that.
getting married on Earth Day.
You should know that I adore her.
No math.
I adore her. She was the first
Yeah.
girl that my oldest son had a crush on.
I don't even remember her.
So, she's a few years older than him, and he was in
She
love.
was in 5th grade. She was like an assistant teacher for my English teacher.
Yeah, she's teaching somewhere else now. Okay, so anyway, this is wrong. And he had some insane way of remembering something that was wrong. I don't know, maybe he's a liberal. No, I didn't say that.
Yes.
Now,
Don't say that to Noah.
oh, poor Noah's a wonderful boy with a wonderful heart. He just doesn't understand true deep liberalism. But anyway, if you want to see something frightening, look up Cloward Piven or look up Saul Alinsky. Those things are terrifying.
The
Anyway,
guy who wrote the book about Satanism.
well, he dedicated it to Satan. It wasn't about Satan. It was about taking over the country, which is fairly much the same. So anyway,
Can I read it?
yeah, Rules for Radicals is the name of it.
Oh, right, he was on.
Anyway, listen, hey, -2 to 5, we fill the circle in, and in case you're suffering from Aunt Jemima disease, and you feel that you, like Dee, just can't get this straight in your head, the best way I know of to remember the difference between the two of them is this. Do you see the little or equal to sign underneath? You could take that ink and use it to fill the hole in. Okay? So if you're someone who gets confused about that, that's a little gimmicky trick
Oh,
that you
that's
can.
smart.
There you go. Hold on one second.
I've been hearing
And
that.
the last thing I want you to realize is the X is in between these, okay? The X is bounded by or in between these. So when I graph it, I have to do this. And this is very important. Your graph should be like obvious that it's more than just the line. Okay? Anthony?
It like makes more sense that if you colored in, it wouldn't be equal to. Cause like you can't use that, so like it's darker. If you could use it, it'd be open.
No, that's ridiculous.
That's how I.
But-
Let me
Makes
explain.
sense.
Let me explain. If the darkened here means it's allowed to be equal to it, wouldn't the darkened here also mean that you're allowed to equal to it?
Oh,
Or
fire.
do you believe that the darkened here suggests that by being lighter here, you would also be equal to it? You do see how that could be confusing, right?
No, I don't even know what.
All right, let's go now to the next one. So obviously on this one, my marks are 2 and 7, but there's a really big different word in the middle. The word is or. It is X is less than or greater than 7, so here's my open circle on 7. Do I fill that circle in?
No.
Very good. Arrow to the right because, listen, whenever the letter's on the left, the direction of the inequality tells you the direction of the line you're drawing. Okay? And then this one says it's less than or equal to, so I can fill that circle in and go to the left. Okay? A bounded interval, like the X here in between, means you're gonna shade in between. A non-bounded interval means you're gonna go in opposite directions. The way I can explain it is, if you see or, I don't know if you remember this song from many, many, many years ago. I would think that you would not because you're too young, but each year the kids remember it because they waste a lot of their time watching MTV and stuff like that. But there's this song from years ago where you walk like an Egyptian.
Yes.
No, there you go. Okay, well, this is, get it? Walk like an Egyptian. You see the or?
I never heard this.
And now, last year, we had a kid in class, Jason, I forget his last name at the moment, I'm getting old. But Jacob Dukowitz, he was able to slide his head this way. Like, it was really strange. It looked like it came off of his spine. And it would go like, I don't know how he did it, but he was remarkable at it, most remarkable. Okay,
Not like that. I think Kristen can do it. Please.
go ahead.
It was
Come on,
so
walk like.
fun.
I look like I'm having a spasm. Yeah, there you go. That's it. Very good. Okay. Now, a little bit of quick review here. The thing to remember on this first one, kids commonly mess up. Everybody will get n to the 12, but you have to remember it's 64 n to the 12. Because this cube also refers to the 4 in front. It refers to everything in the package. Next up, likewise here, this is going to be 16x to the 12. Then when I do 4x times 16x to the 12th, I'm going to get 64x to the 13th over 8x to the 5th. Dividing coefficients, subtracting exponents, I get 8x to the 8th. Negative exponent. So this becomes 5 halves squared, which is 25 over 4. Of course, you could do it on your calculator. Put the parentheses around the 2/5, up arrow, -2. It'll give you an answer, then you go math, enter, enter, and it will convert to a fraction for you. Yes?
Would it be allowed to keep it in 5 over 2?
Depending on the directions, if the directions say to write with a positive exponent, which they frequently do, absolutely, but here it said to simplify, so then you are expected to go further. Okay, now, let's take a look at some of today's lessons here. Today, we start translating expressions, and we need to come up with words, Spencer, that suggest particular operations in mathematics. What are some words that indicate that you should add? Fire away, Kristen.
Some.
What was that?
Some.
Some, good. Another one. Hey. Behave. Some, nice. Okay, Spencer.
More.
More than.
More than.
Okay. All right, good. Go ahead, Anthony.
Plus.
Plus, very good. Anybody else? Go ahead. And may or may not, you know. Go ahead.
Combine.
May or may not. Here are some, ready? There's exceeds. Okay, increase. Those are all words that suggest addition. Now, to those words, there are sister words for subtraction. Sum, what would be the sister word for sum?
Different.
Difference. More than?
Less than.
Less than, good. Plus? Increase?
Decrease.
And then exceeds, the sister word is not so obvious, it's diminish. Okay.
Diminish.
Diminish. Okay, so there we have some words for that. Multiply,
Like,
Times.
like
times.
like twice.
Yeah, you could say twice, you could thrice if you're British.
Rice.
Thrice, yeah.
Like rice.
Product.
Product. And the other one that a lot of kids struggle with until I remind them is of. Now, of is not always going to be multiplied, but it's particularly used with fractions and percents. It'll say 25% of or 1/4 of. And divide, there's really one dominant word that means divide. What would that be?
Divided by.
Quotient. Very good. Yeah, if we see divided by, obviously we're there, but quotient would be the next one.
I can I just have two words that could also be for divide.
The last one is quotient. We will just rock it through now and translate some phrases. Carissa?
I don't know if this is gonna go for multiplication too, but for divide, can it be each?
It all depends because it could indicate it, but it doesn't strongly indicate it. Yes.
Could you also use dividend for divide?
For parts of division, sure. But the big one we're going to see is quotient. Now, another word that tends to indicate divide is per.
Per?
Yeah, like per gallon, miles per gallon, that kind of thing. Okay, so, guys, in the game. How would I write an algebraic expression for three more than a number? Go ahead. I would rather see you write n plus 3. Because with the phrases more than and less than, there's a certain sense of order. For example, let's say Emma has $5 more than me on her. Isn't it true that to understand or to figure out, compute how much Emma has, you first have to see how much I have? Right? So if I have 10, Emma has
15.
If I have 1 billion, Emma has, I'll be very happy. Now, less than, what would the next one be?
N minus 5.
N minus 5. Now, you guys all know that one of my favorite singers in the world is Bruce Springsteen, and he has a song called The Ghost of Tom Joad. And in the song The Ghost of Tom Joad, he quotes a verse from the Bible, where he says, waiting on the day when the last shall be first and the first shall be last. Okay?
Whoa.
Now, every time that I see more than and less than, I think to myself, waiting on the day when the first shall be last and the last shall be first. Watch, ready? Last, first. First, last. First, last, last, first. So that's only done with more than and less than. When you see more than and less than, you switch the order. The first shall be last and the last shall be first. Okay? Next one. 7 less than 4 times a number. What would that be?
4n minus 7.
4n minus 7. Nice. Next up. 8 increased by a number n. 8 plus n. And the next would be 10 minus 2n. So we'll go home tonight, play with some translations, and tomorrow we'll come in and start working them into equations. Hasta la vista, vaya con Dios, toodaloo, ta-ta, arrivederci. Smile a lot, ciao, Wiedersehen, adios amigos, amigas. Cheerio, Karusha, Gaddafi.
I have a question about like,
Yeah, let me just, kill the